The arc length. In a circle, a central angle whose radian measure is theta subtends an arc that is the fraction theta over 2 pi. So in this, for this example, that's the fraction of the whole circumference of the circle is this one. That's pi over 2 pi. 2 pi is the whole circle or the circumference of the circle. So we are just, the theta here or the angle here is just a fraction of the whole circle, of course. Thus, in a circle of radius r, the length of the length s, or the arc length of an arc that subtends the angle theta is s, is equal to theta over 2 pi times the circumference of circle. So the circumference of circle is 2 pi r, if you remember that in your junior high school. So theta over 2 pi times 2 pi r. So we will cancel this one. So theta and r. So that's r theta. So the length of an arc is s is equal to r times theta, where s is the length of the arc, r is for radius, and theta is the angle in radian measure. Take note, this one must be in radian measure. If the given is in degree measure, convert it first in radian measure before you solve this for this formula. Okay, find the length of an arc of a circle with radius 10 meter that subtends a central angle of 30 degrees. So the given here is the radius, which is 10 meter. The theta here, or the angle, is 30 degrees. And of course, we will be locating the length of an arc. So the formula is S is equal to R times theta. Okay, so the given here is 30 degrees ang atong angle. Therefore, we should convert it first from degree to radian measure before we would apply this formula. So 30 times pi over 180. So this is, we can simplify this one. So let's divide the numerator and the denominator by 30. So this is 1 over 6. So pi over 6 rad, or our angle is pi over 6 rad. So we will use this one for our formula now for the length of an arc. So the length of an arc, or S, is equal to 10 for radius times pi over 6 for theta. So that is 5 over 3. So the answer is 5 pi over 3 meter. So another example here, a central angle theta in a circle of radius 4 meter is subtended by an arc of length 6 meter. We will find the measure of theta in radians. Okay, so the given here is in radius 4 meter and the length of an arc is 6 meter. Now we will be locating the angle or the theta in radian. Of course, if we use this formula, so we know that to identify the radian, the angle, it is already in the radian measure. So the S here is 6 and the R is 4. So we will have another formula to locate the angle. So we will divide this R. So theta is equal to S over R. So our S is 6 and our R is 4. So that's 3 over 2 rad. So that's the answer. Okay, the area of a sector. If a central angle of a sector has measured theta radians, then the sector makes up the fraction, again, theta over 2 pi again, of a complete circle. Since the area of a complete circle with radius r is pi r squared, this is the area of a circle, pi r squared, if you remember that again in your junior high school. So we can identify the formula to get the area of a sector with this one. So the fraction, which is theta over 2 pi, times the area of the circle, which is pi r squared. So matanggal lang is the pi. So that's 1/2 theta r squared. So the area of the sector has this formula, 1/2 theta r squared. So for an example here, we will find the area of a sector of a circle with central angle 60 degrees if the radius of the circle is 3 meter. Okay, the radius is 3 meter. The angle is 60 degrees, and we will be looking for the area of the sector. Now, we have the formula, of course, which is area is equal to 1/2 times theta r squared. Now, you observe that this is in degree measure. So let's convert it to radian measure again. I forgot to tell you that here also the same with the length of an arc, the angle here in area of the sector must be in radian measure. So before we apply the formula to get the area of the sector, we should convert this degree to radian measure. So 60 degree times pi over 180. So let's simplify this one. So we could divide the numerator and denominator by 60. So this is 1/3. So the answer is pi over 3 rad. Okay, so using this one for our theta. So area of the sector is equal to 1/2 times r squared, which is 3 squared, which is 9, times pi over 3. So 9 times 1 is 9. So 9 over 2 times pi over 3. So 9 pi over 6, or that's equivalent to 3 pi over 2 meter squared. Meter squared because our radius is m. So m times m is m squared. Another example, a sprinkler on a golf course fairway set to spray water over a distance of 70 feet and rotates through an angle of 120 degrees. Find the area of the fairway watered by the sprinkler. Given here is the radius 70, an angle theta which is 120 degrees, and of course we will locate the area of the sector. Okay, this is the formula, 1/2 theta r squared. So of course our theta here is still in degree. Let's convert it first to radian. So 120 pi over 180. So let's simplify this one. Let's divide the numerator and denominator by 60. That's 2 and 3. So 2 times pi is 2 pi over 3. So we will use that for our formula. 1/2 times the radius is 70. So 70 squared times 2 pi over 3. So 70 squared is 49. So 4,900 over 2 times 2 pi. So that's 4,900 pi over 3. We will be locating the area of the fairy watered by the sprinklers. So 4,900 times pi, which is 3.1416, divide 3. If we punch our calculator, that's approximately 5,131 square feet.